Alright, ladies and gentlemen, welcome back to this Athenian Stranger tutorial video where today we are going to move on to part 2 of our discussion of translations. This video will consist primarily of practice problems. The part 1 video was the vocab and knowledge prep. This video covers TEKS 3A and 3C for geometry. In this video, you will learn how to translate a triangle on the coordinate plane and find its area. You will also learn how to translate a quadrilateral on the coordinate plane and find its area. And finally, you'll learn how to write vector translation rules, use prime notation, and visualize both pre-images and images of figures. There are really two TEKS covered in this lesson. This is part of the transformations strand. TEK 3A says that the student is going to learn how to describe and perform transformations of figures in a plane using coordinate notation. And TEKS 3 says the student will identify the sequence of transformations that will carry a given pre-image onto an image on the coordinate plane. More or less a reiteration of the previous slide. There are really three small homework parts that come together. Shouldn't take more than 30 minutes or so. Part 1 is to complete problems 1, 5, and 6 from the warm-up and watch the solutions video for any missed problems. All of those problems from the warm-up will be shown in this video. Part 2 is to complete the translation problem on page 2 of the packet and watch video to reinforce learning. That will also be shown here. And part 3 is to scan pages 174 to 192 in the Big Ideas Geometry textbook to see a different presentation of this material and prepare you for the next lesson. There will be a link in the description and the pinned comment. This lesson fits into a series of lessons. Yesterday, we learned the vocabulary for translations and vectors. Today we're going to apply our knowledge and practice the skills needed to solve translations problems. And next up, you will learn how to perform a composition of translations. That would be more than one translation. And then learn about rotations and dilations before moving on to non-rigid transformations. The transformations we're doing now with these translations, they're rigid in the sense that they don't change any of the dimensions of the shape. And they preserve similarity. The dilations that we'll do later will preserve similarity, but when we move on to non-rigid transformations, the resulting shapes will look different from the starting shape. So the pre-images and the images will be dissimilar from one another. There are 4 key resources here to help you learn and succeed. The primary resource is this video, which contains the complete lesson and solutions. There will be a notes key, so everything that we write in this video will be available to you as a notes key PDF linked in the description and pinned comment. You have the textbook itself. A link to chapter 4 of the Big Ideas Geometry textbook will be linked in the description and pinned comment. And finally, an audio-visual and multilingual glossary will be linked in the description and comment. So you have multiple resources here to help you learn and succeed. Of course, the resource that's not listed is me. Please reach out if you need help. You can contact me through YouTube in a comment, through email, or through Remind. Okay, let's transition now to the worksheet itself. Our first task is to complete a warm-up, and I'm simply going to proceed through this 1 through 6 in order, but the warm-up problems will be 2, 3, and 4, and then 1, 5, and 6 will be homework problems. But I'm going to do all of them. Number 1. Find the midpoint of DF, segment DF, if D is at 7, 2, and f is at 3, negative 6. So we're looking for midpoint E, and we're looking for the coordinates of midpoint E. Of course, the most important thing to remember is the midpoint formula, which looks like this. This is really not so much a formula as a pair of formulas that find the coordinates of the midpoint. So we take the average of the x values, x1 plus x2 divided by 2, and that gives us the x-coordinate of the midpoint. And then we take the average of the y values, y1 plus y2 divided by 2, and that gives us the y-coordinate of the midpoint. So as you see here, I've really just formed a coordinate pair. In order to plug in the correct values, we should label our points that were given. So this would be x1, y1, x2, y2. And now we can plug those values in. So let's rewrite m, open parentheses. So now we have 7 plus 3 divided by 2. 7 plus 3 over 2. That will give us the x-coordinate of the midpoint. And then 2 plus negative 6, or 2 minus 6 over 2. Will give us the y-coordinate of the midpoint. Simplifying further, we can reduce these fractions to whole numbers now. 7 plus 3 is 10, and 10 divided by 2 is 5. 2 minus 6 is negative 4, and negative 4 divided by 2 is negative 2. So the x and y coordinates of the midpoint are 5, negative 2. And that's number 1. Number 2, find the coordinates of endpoint S if Q is located at 1, 5, and R is located at negative 1, negative 3, and R is the midpoint of segment QRS. So this problem is asking us to find not the coordinates of the midpoint, because we have those coordinates already. They're asking us to find the coordinates of the other endpoint. Here's one endpoint, and we're looking for the endpoint S coordinates. So we're looking for an x and a y value. Here's how we set this up. First, write the midpoint formula. x1 plus x2 over 2, comma, y1 plus y2 over 2. Okay, so those are the coordinates. Now, we already know what the x-coordinate of the midpoint is. Remember, this little formula here will give me the x-coordinate of the midpoint. That's negative 1. So this is the x-coordinate of the midpoint, x sub m. This is the y-coordinate of the midpoint, y sub m, negative 1, negative 3. So this little formula equals negative 1. This little formula equals negative 3. So the way we figure this out is we say, well, what else do I know? I know what x1 and y1 are. It's 1, 5. So I can substitute in 1 and 5 for x1 and y1, then set these little formulas equal to the midpoint coordinates and solve for the missing values, which would be x2 and y2. So here we'll just create two little formulas here, two little equations rather. 1 plus x2, okay, 1 is x1, plus x2 over 2, and that equals the x-coordinate of the midpoint, which is -1. So here we're going to solve for x2. For y, we already know what y1 is, so 5 plus y2 over 2 equals the y-coordinate of the midpoint, -3. So our task is just to complete these two little equations. To get x by itself, I'll multiply both sides by 2. The benefit there being that it cancels the denominator. And now I have 1 plus x2 equals -2. Subtracting 1 on both sides will isolate the x variable on the left. So x2 equals -3. So the x-coordinate of endpoint S is -3. Now for the y value, to get rid of the 2 in the denominator, I will multiply both sides by 2. Chief benefit being I can cancel out the 2's on the left. And now I have 5 plus y2 equals -6. Subtracting 5 on both sides, I isolate the y2 variable, and y2 equals -11. So the y-coordinate of endpoint S is -11. So the full coordinates of endpoint S are -3, -11. Number 3, we're asked to simplify a rational expression with a square root in the denominator. What we have to do is rationalize the denominator. And what that means is we have to get rid of the square root in the denominator. The process that you use to accomplish this goal is called multiplying by the conjugate. I just want to write this word here. The conjugate. Conjugate. You see that word in Spanish. The conjugate for this expression is 2 plus square root 3, because this is 2 minus square root 3. The conjugate would be 2 plus square root 3. So watch what we do here. We can only multiply a fraction by something that reduces to 1, so I'll multiply both the numerator and the denominator by the conjugate of the denominator, which is 2 plus square root 3 over 2 plus square root 3. Now, it's fairly straightforward in the numerator. We'll just distribute the 2 through both terms of that parenthetical expression. In the denominator, it's less clear what to do. But if we put parentheses around these two expressions, we see something that looks a lot like multiplying two binomials together. And in order to multiply two binomials together, we use FOIL. Use the FOIL method: first, outer, inner, last. It's pretty fascinating what's going to happen here in a moment. But let's draw those lines that at least help us know what to do. So first terms are 2 times 2. So that's where they will go, multiplied together. The outer terms are 2 times the square root of 3. And we'll put those guys right here. With these problems, I'm always fascinated that it's even possible to do this. Now the inner terms, that would be negative square root 3 times 2. So that would be these two guys right here, multiplied together. And then finally the last terms. And that would be negative square root 3 times positive square root 3. And those two guys would go right here. Okay, so at least we know what to multiply. 2 times 2 is 4. Now, that was the first terms. The outer terms are 2 times square root 3, which we can just write 2 square root 3. The inner terms are negative square root 3 times 2, which we can write as negative 2 square root 3. In between these two values, I should put a plus symbol. Since this is positive, that's negative. Finally, the last terms, negative square root 3 times positive square root 3. In side work, let's make sure we understand that the square root of 3 times the square root of 3 will give me 3. All right, it just gets rid of the square root. Putting a negative sign in front of one of those square roots, simply on the answer, it'll just preserve the negative sign. So negative square root 3 times square root 3 is just negative 3. Now watch what happens here. As with most of these FOIL problems, you end up with common terms in the middle. And 2 times square root 3 minus 2 times square root 3, well, that's just 0, right? So the next stage of simplification would just be 4 plus 0 minus 3. Right? So essentially 4 minus 3, which is just 1. So the whole denominator there becomes 1. And that's fascinating. So now let's distribute the 2 to both terms in the parenthetical expression in the numerator. And what I'm going to come up with here, here's my numerator and denominator. In the numerator, I have 2 times 2, that's 4, and 2 times square root 3, so 4 plus 2 square root 3. In the denominator, I just have 1, right? So this whole thing becomes this, which can be written a little bit more elegantly as 4 plus 2 square root 3. So that problem, simplified, becomes this expression right here, 4 plus 2 square root 3. Now that's a number. That is a number. If we want to approximate its value, we could type in 4 plus 2 square root 3, and we would get 7.464. So we could say approximately equal to 7.464. It's interesting, right, that it reduces down to an elegant little expression like that. This is the one we would want as our answer right here. And that's how you use the conjugate. It's a pretty neat trick. Number 4, solve 8 equals square root r over 5. All right, so there's a rule about square roots, and that rule is very important here. The square root of a over b can be written as the square root of a over the square root of b. That will be the first trick we'll exploit. So I'll rewrite 8 equals, but instead of this huge square root, I'll write 2 small square roots. Square root r over square root 5. Now, to get rid of the denominator here, I'll simply multiply both sides of the equation by square root 5. And the chief benefit of doing that is that I can cancel the denominator on the right side. Now on the left side, I have 8 square root 5 equals square root r. Now, how do I get rid of the square root r? Well, another rule, the square root of r squared equals r. All right, so I just need to square both sides. So I will square both sides. Chief benefit of doing that is to get rid of the square root on the right side and isolate the r variable by itself on the right. Now I have r equals. Now, one final trick about radicals. Let's take 8 square root 5 and let's square the whole thing. This is equal to 8 squared times the square root of 5 squared. And we already know that when I square a square root, the square root just goes away. Remember this rule right here. So what we'll end up with, well, we'll do it down in the problem. I've got here 8 squared times the square root of 5 squared. Now my next line will say 8 squared is 64. I've got 64 times 5. Because squaring the square root got rid of the square root, and I'm just left with what's underneath the square root. And that's equal to r. So this all comes down to a simple multiplication, 64 times 5. 4 times 5 is 20. 6 times 5 is 30, plus 2 is 32. So 64 times 5 is 320. Therefore, r equals 320. Okay? That's number 4. Moving on to number 5. This problem looks harder than it is. First thing we're going to do is try to get closer to this x by itself by getting rid of this negative 9. Let's add 9 to both sides. That's 0 on the right. Negative 5 plus 9 gives me positive 4. So now I have 4 equals the square root of 16x. Now remember our rule. The square root of a times b is equal to the square root of a times the square root of b. This only works for multiplication. It doesn't work for addition or subtraction. So I'm going to rewrite this now. Rewrite 4 equals the square root of 16 times the square root of x. That's beneficial to us because the square root of 16 is just 4. So now 4 equals 4 times square root x. Okay, well now I can divide both sides by 4 to cancel the 4 on the right. Well, these cancel, but interestingly, these cancel as well. So 4 divided by 4 is just 1. So I'm left with 1 equals the square root of x. And now I'm going to use my trick from up in problem 4. I'm going to square the square root to get rid of it. And what I do to one side, I have to do to the other. So I'm going to square the square root, and I'm also going to square 1. So now I have 1 squared is 1, equals x. And that's it. This whole thing equals 1. Pretty neat. Final problem, solve and we're given a quadratic expression over a quadratic expression, and that whole thing is set equal to 1. Again, harder. It looks harder than it is. This whole denominator can be gotten rid of simply by multiplying both sides by it. Right? So I can multiply both sides by x squared plus 10x plus 25. Okay, on both sides, x squared plus 10x plus 25. The chief benefit of doing that is that when I do that on the left, I can cancel those two and get rid of the denominator. On the right, I'm only distribute multiplying a 1, so it doesn't change anything. Simplifying here, I'll write x squared plus 5x plus 10, because the only thing I have remaining on the left side is the numerator, equals x squared plus 10x plus 25. And now there's a process here of combining like terms. We need to subtract x squared from both sides. Okay. On both the left and right side, I get 0. Now I've simplified to 5x plus 10 equals 10x plus 25. Okay, again, I can subtract 5x from both sides. And here I've got 0, and here I've got 5x. So now I have 10 equals 5x plus 25. Okay? Now, what I need to do is subtract 25 from both sides to try to get x by itself. 10 minus 25 is negative 15 equals 5x. Now to get x by itself, I just divide both sides by 5. Right? The chief benefit there is the 5's cancel on the right, leaving x by itself equal to negative 15 divided by 5, which is negative 3. So x is negative 3. Right? And those are the 6 warm-up problems. Okay? The reason we're doing these is because the Algebra 2, pre-calculus, trigonometry, upper level math, calculus, by the time students get to these stages in their math education, they seem to have forgotten how to do all this stuff. And so because geometry is so different, we want to make sure that we keep reinforcing these algebra skills. I mean, we're not just teaching geometry, we're teaching mathematics. So it's very important that we keep reinforcing everything that you would possibly need to know. Okay, moving on. Here's really the lesson content for the day: how to translate figures using vectors. All right, this is what we all came here for. And this is the worksheet that we'll fill out here. All right. Best way to learn is to dive right into an example. Example: given A, negative 3, comma, negative 5, and B, negative 2, comma, 1, translate using vector 5, comma, 4. Now the solution process to these problems is the same regardless of their difficulty or complexity. The very first step is to write a translation rule. All right, so we're going to write a translation rule. And so once we write a translation rule, we will solve for prime coordinates. This language will make more sense in just a moment. And we'll go over it again once we do the problem, and you'll see what we mean. Write a translation rule and solve for the prime coordinates. Okay, so here's kind of the template that you need when you do these problems. And I just want to point out one thing. This series of 3 dots in the shape of a triangle, this means in mathematics, it means therefore. Right? That way we don't constantly have to write therefore. We can just put that little symbol. Okay, so what we need to do is take both our A coordinates and our B coordinates, and we need to move them according to the vector that we have been given. From our last note set, we learned that this position, this first position in the vector coordinate, is the horizontal motion. The motion along the x-axis. All right, and that makes sense. It's in the x position. This coordinate right here in the y position, that's the vertical motion. Vertical. All right? And that makes sense because the vertical axis is the y-axis. Okay, so when we think about moving, we have to move each coordinate. Right? It's kind of very similar to what we were doing with fractional distance. Okay, now the first blank space right here, that's going to say A prime. A with an apostrophe after it is read, A prime. And this is the image coordinate. This is the pre-image coordinate. Okay? So now what we need inside here are x and y coordinates of the image. We start with -3, and we're going to add the horizontal component of the vector. So 3 plus 5. Okay? And then we need -5, which is the y component of the pre-image, plus the y component of the vector. Okay? So -5 plus 4. All right? So let's read this out loud. For A at -3, -5, A prime is at -3 plus 5, -5 plus 4. Therefore, A prime is at 2, -1. -3 plus 5 is +2, -5 plus 4 is -1. So that's where the A coordinate lives after it's been translated. Okay, so here's the other coordinate, B. For B located at -2, 1, B prime will be located at -2 plus the horizontal component of the vector, plus 5, and y, so this is 1, plus the vertical component of the vector, almost wrote 5, 4. Okay, so therefore, B prime is located at -2 plus 5, which is 3, comma, 1 plus 4, which is 5. These are the coordinates of the image. Okay, so these are the coordinates of the pre-image, and these are the coordinates of the image after translation. Okay, that's the bigger idea here, right? Remember, these 3 dots mean therefore. Let's work another example. This one has a picture. Pictures are helpful. Given triangle DEF, that's the one plotted right here. Given triangle DEF vertices D at -8, -5, E at -6, -2, and F at -3, -5. Translate using vector 10, 7, and then find the area of triangle D prime, E prime, F prime. Okay, we'll worry about the area in a second. First thing we're going to do is write a translation rule and solve for the prime coordinates. Now you know what that meant. It's the same process as we did above. We're going to take the beginning coordinates of our pre-image. This is our pre-image right here. So the first value would be the x coordinate, -8. Okay. Down here it would be -6. And down here for F it would be -3. And what we're going to be finding here is D prime, E prime, and F prime. These are the coordinates of the image post-translation. Okay, so now we add the horizontal component of the vector, which would be 10. So +10, +10, +10. Then we take the y components of the pre-image, -5, -2, -5, -5, -2, -5, and we add the vertical component of the vector, 7 + 7 + 7. All right? So these numbers will always be the same. These numbers will always be the same. Therefore, right? So again, D prime, E prime, F prime. D prime will be located at -8 + 10 would be +2. -5 + 7 would be +2. So D prime is located at 2, 2. E prime is located at, the x value would be -6 + 10. That's +4. And the y value of E prime is -2 + 7, and that's +5. Okay, for F prime, the x value of the image would be -3 + 10, which is +7. And the y value of the image would be -5 + 7, which would be +2. So here are the coordinates of our image. This is our pre-image. Here are the coordinates of the pre-image. This is our image. We need to go ahead and draw the image. So graph new triangle D prime, E prime, F prime, and sketch the vector paths. Vector paths are easy. But let's draw that triangle first. So D prime is located at 2, 2, right here. Make sure to label it D prime. E prime is at 4, 5, and that would be right here. Okay, and that would be E prime. And F prime is at 7, 2. Okay, here's 7, 2. And that's F prime. Let's connect them together to make a triangle. All right, very good. Now we're going to draw our vector paths. All you do is connect your pre-image point to your image point. So we can connect D to D prime. Use a straight edge for this. Use a dotted line notation style like this. Sketch it in as a dotted line or a dashed line. Okay, see that? Now connect E to E prime. Dashed line. And then F to F prime. Dashed line. Now we want to indicate the direction, so when anyone looking at this picture 10,000 years from now, they'll know that we went that way. Okay, so there's your direction. We need to indicate two more things. These, remember the rules for the translations, rigid translations like this. These lines will be congruent in length, and they will also be parallel to one another. So that's like a filled in arrowhead, like that. So draw those two symbols there, the dashed lines, the hash marks, whatever you want to call them, and then the three arrowheads to indicate that they are parallel. And now you've drawn you got the pre-image, the image itself, and you've sketched in the vector paths. All right. So that's the full solution to the first part of this example. Now the second part is more or less a little geometry problem, a little math problem, to find the area of triangle D prime, E prime, F prime. And you probably know this already, but the pre-image and image of any translation that is rigid, those would be identical. All right, those would be congruent. So it doesn't matter whether we're finding the area of DEF or area of D prime, E prime, F prime. I've drawn a little, I'm going to write in here, the areas of triangle DEF and triangle D prime, E prime, F prime are the same. From the graph, we can see this little shape. So I've just taken this and I've put it here, and I've drawn this dotted vertical line to show that there's a right angle. We have to find the area of this two smaller triangles and then add them together. So first we need to recall that the area of a triangle is equal to base times height divided by 2. Okay, well, we know all the values here. Let's look at the graph. Let's look at the graph. If I were to draw in that vertical dotted line right on the graph, you would see that it would separate this base into two pieces. This left piece has 2 spaces, and this right piece has 3 spaces. So I can label this now 2 and 3. What's the height? Okay, the height is 1, 2, 3 spaces. So the height is 3. So here are my two smaller areas. We'll first find the area of this little triangle here. That's 2 times 3 over 2. Base times height divided by 2. And that would equal 3 units squared, right? The second triangle area would be 3 times 3 divided by 2. So 3 times 3 divided by 2. And that would equal 9 over 2 units squared, and 9 divided by 2 is 4.5. 4.5 units squared. So you just add these two smaller areas together, 3 plus 4.5, and that equals 9. I wrote 9. 3 plus 4 is 7. It equals 7.5 units squared. All right, that's the combined areas. So the total area of the triangle is 7.5 units squared. All right, so that is the end of the lesson, but we'll go ahead and work on this homework problem so you can watch it all in one video. So in this one, we're given a quadrilateral, and that would be a shape with four vertices on it, 4 sides, 4-sided shape, quadrilateral. Quadrilateral A, B, C, D with vertices at these coordinates. So translate using vector 3, -1, and then find the area. All right. So the very first thing we need to do, because we have a blank graph, is we need to plot the pre-image. Plot the pre-image. Okay, that's what we should do first. Let's draw it. So we have a coordinate here at A, which is -1, 2, -1, 2. That's this point right here, and that's point A. Now I've got a point here at -1, 5, right here, and that's point B. Here I've got a point at 4, 6, right, and that's point C. And now I've got a point D at 4, 2, okay, and that's point D. Now let's connect the dots. So we draw this pre-image. Okay, connecting B to C now, and then C to D. And now A to D. Great. Okay, so we've plotted the pre-image, and now we need to, so that was step one. Now step two is to find prime coordinates. And that would be the coordinates of the image. We plotted the pre-image, so we would find the prime coordinates of the image. In other words, we're performing the translation. All right. So let's see what we've got to do here. We're going to do the, we're not going to worry about the area till later. So the first part of the solution is the translation part. So we can write for A located at -1, 2, right? We find that A prime is located at -1 plus the horizontal vector component, which is 3, -1 plus 3, comma, 2, which is the y value of A, plus the vertical component of the vector, which is -1. So rather than 2 plus -1, we just write 2 minus 1. Therefore, A prime is located at -1 plus 3 is 2, comma, 2 minus 1 is 1. Right? So we have the A prime coordinate. Okay? So let's do B. For B located at -1, 5, we have B prime located at -1 plus the horizontal component of the vector plus 3, comma, 5 minus 1, the vertical component of the vector, 5 minus 1. Right? Therefore, B prime is located at -1 plus 3 is 2, 5 minus 1 is 4. Right? 2, 4. That's where the B prime image coordinate for B prime is. Now we do for C. C is located at 4, 6. We find that C prime is located at 4, the x value of C, plus the horizontal component of the vector, 3, comma, 6, the y value of C, plus the y component of the vector, or the vertical component of the vector, which is 6 minus 1. Therefore, C prime is located at 4 plus 3, which is 7, comma, 6 minus 1, which is 5. All right, so that's where the C prime coordinate is located, image coordinate. Finally, for D, located at 4, 2, we find that D prime is located at 4 plus the horizontal component of the vector 3, comma 2 minus 1, which is the y component of the vector, or the vertical component of the vector. Therefore, D prime is located at 4 plus 3 is 7, comma 2 minus 1 is 1. All right, so now I've found all 4 coordinates of the image following the application of the vector rule. So a translated image is going to be located at these coordinates. Let's go ahead and plot them in red. So A prime is located at 2, comma 1. That's right here. A prime. Okay, B prime is located at 2, comma 4. That's right here. B prime. C is located at 7, comma 5, and that's here. C prime. D prime is located at 7, comma 1, right here. D prime. Remember, we're now going to sketch well, first we're going to connect those dots, and then we'll sketch out the vector paths and label them appropriately. So let's just connect dots here. It's always the fun part. You know, and these segments, BC, should be perfectly perpendicular to B prime, C prime. All these segments should be perpendicular to their pre-image segments. So just connecting dots to make this quadrilateral. Okay, so now we have the pre-image in blue and the image in red, right? Both plotted on the coordinate plane and labeled. We just need to draw in our vector paths, and all that means is we're going to connect dots. So I'll connect A to A prime using a dashed line, dotted or dashed, doesn't matter. Dashed line here. Okay, the direction of that vector was this way. From B to B prime, dashed lines. Right. C to C prime. And you know, you could start to see how in the future you will be able to work out the volume of a shape formed by this picture. All right. And then here D to D prime. Okay. Final thing we got to do is label that these lines, these little lines will indicate that all these dashed lines are congruent to one another. And they're also all parallel. Right. There's little parallel symbols everywhere. So that's your full drawing, and that's the completed part 1. The next part's the area. Okay, so now we're going to find the area of the image. Find area of quadrilateral A prime, B prime, C prime, D prime. You know, just like the other problem where we found the area of that triangle, it's the same area as A, B, C, D is the area of A prime, B prime, C prime, D prime. A challenge question for anyone out there interested in it would be to find the volume of this shape. I'd like to see somebody do that as a real challenge, especially the pre-AP kids. You should find the volume of this shape. But let's find the area of A prime, B prime, C prime, D prime. Let's draw a little picture to represent this situation. Okay, this is kind of a rough approximation of what the shape looks like on the coordinate plane. It just helps to sketch it out a little bit. And we see here that we've got a chance to put in a dotted line and create a right triangle, right here. So now I'm going to find two smaller areas. I'll find the area of the triangle, and I will add it to the area of the rectangle. Okay, and just so we remember, the area of the triangle is base times height divided by 2, and the area of the rectangle is length times width. Right, these are our formulae. Now the area of the triangle, we better label these, right? So we need to go in here and look. If I put this dotted line in here on this image, like this, put in that right angle symbol, I see that there are 1, 2, 3, 4, 5 spaces. So this would be 5, and that means this would be 5. Okay, this distance right here, 1, 1, 2, 3. So this is 3, and this is 3. So this little piece right here, this little piece is 1. Right? So to find the area of the triangle base times height divided by 2, that would be 1 times 5 divided by 2. That equals 1 times 5 divided by 2. 5 over 2 is 2.5. So this triangle area is 2.5 units squared. The area of the rectangle, length times width, 3 times 5. So the area of the rectangle is 3 times 5, which is 15 units squared. So the area of the quadrilateral, area A prime, B prime, C prime, D prime, equals 2.5 plus 15 units squared, which is equal to 17.5 units squared. All right. Here's the kind of lingering question here, challenge question. What's the volume? What is the volume of the three-dimensional shape formed by all these points that you can kind of see there? It looks like half of a house, right? You've got the roof here, right? Here's the house part. I'd like to see somebody show me how we can find, we would know how to find the volume pretty easily of this piece here, right? This rectangular prism down here, and then you have a triangular prism here. So anybody interested in doing it, volume is just length times width times height. So this length times this width times this height, right? And then you take that volume and you add it to the volume of this triangular prism up on top, which would just be base times height divided by 2, or the area of this triangle times the length, the distance from C to C prime. All you would need to work out, okay, you would need to take the area of this rectangle and multiply it by the distance, okay, the vector distance. And then you would need to take the area of the triangle, multiply it by the vector distance, and then you just add those two volumes together and you would get it, all right? So how would you figure out what the distance is between these 2 points? Well, you know what you would use? You could use the distance formula, right? You could use the distance formula to find the distance between those 2 points. So I'm going to hold off for just a second here and wait, okay? I'm going to give you a minute to look at that and think about it, because I'll show how to find the volume here in just a moment. But this is the challenge question. So don't read on until you've given it a try, right? This is not homework, it's a challenge problem. Okay? So let's move on to the challenge problem. This is something to leave your brain twisted. All right. So we want to find the volume, right? First, we have to work out the distance between, and it doesn't matter which pair of points we use. We need to know the distance between the pre-image and image coordinates. All right, so here's the distance formula. Distance equals the square root of the sum of the squared differences in the y's and the x's. All right, so this is x2 minus x1, y2 minus y1. So let's fill it in. All right, we need two coordinates. So let's just take a look here. We've got coordinates here for d and d prime. Let's use those. So d, because it doesn't matter which coordinates you use. D is located at 4, 2, and d prime is located at 7, 1. All right. So this would be x1, y1, x2, y2. So let's go and plug in our values. D is located at this, or the distance is the square root of, right? We'll put a plus sign there, and then here, these open close parentheses, squared, squared, and we'll fill this out. X2 is 1, or sorry, X2 is 7, minus X1, which is 4. Then we'll square that, and now we've got Y2, which is 1, minus Y1, which is 2. Okay? So that means that the distance equals the square root of 7 minus 4, which is 3 squared, plus 1 minus 2, which is negative 1 squared. All right, we have to square those things. So now D equals the square root of 9 plus 1, because negative 1 squared is 1, and 3 squared is 9. So the distance is equal to the square root of 9 plus 1. So now the distance is equal to the square root of 10. Right? Now, we can approximate what that is, but we're not going to use that right away. We'll do it at the end. So we'll just leave it. We're going to use that distance. That is going to be one of the pieces of our volume calculations, but we're going to leave it in its exact form, in the square root form, but just so you can see what it is. It's like 3.16. So we'll just keep that tucked away in the back of our head. But that's this distance here. Okay, so I'm gonna label this now. Well, I don't want to give away the game. I don't want to label that. I'm gonna draw let me draw another little picture here. Okay. So basically, I've got a quadrilateral that is composed of two parts. One part is a rectangular shape, and then there's this vertical piece coming off of the top. I mean, this triangular shape coming off of the top, like this. That's kind of what I'm working with. And that has a distance. So I'm going to draw like a little picture of like a house or something. Make everything, attempt to just sketch it kind of correctly. Okay. Try to keep it parallel. All right, just checking what I'm doing here. All right. Okay, and then there's this piece down here. Then finally, there's this piece over here. Okay, now we'll connect those pieces. All right, so we've got like a little, see what I meant by like a little house? Okay. See that? And then there's this piece, looks like this. So it looks kind of like a little architectural drawing. And essentially, oh, I got one more, so I better draw in this. Okay, so you can see what we're doing. We're gonna find, let me clean this up a little bit. This little guy, it just looks bad. All right. There. Okay, so basically we're gonna find the volume of this piece here and the volume of this roof. And then we'll add those two volumes together. So, you know, think of this like a house, like a part of a house or a part of a shed or something. The volume of the roof piece, that's going to be the area of the triangle, okay, times the length of the roof, which is square root of 10. All right, so that's what we found. The square root of 10 was this distance. So we should label what we know. We know that this is the square root of 10. All right, we know that this is 3. This is the square root of 10. All right. We know this distance here. All right, this distance is 5. This distance is 5. We know this little piece here is 1, and this is 3. We have enough information, and we've already found the area. All right, so we have the area of the triangle. Remember before we found that the area of that triangle piece was 2.5 units squared, right? So 2.5 times square root 10 is going to equal the volume of the roof piece. .5 times square root 10 equals approximately 7.9, right? We could take it out to 2 spaces and say, okay, this is equal to 2.5 square root 10, and that would be units cubed for volume, and that is approximately equal to 7.9, I guess I'll just leave it to one decimal place, 7.9 cubic units, so 7.9 units cubed. That's the roof, right? This is the roof piece. Now for the volume of, we'll call it the house piece, or yeah, the house piece. So we got the house and we got the roof. The volume of the house piece is just going to be 3 times 5, or the area of this rectangle, times the distance, all right, the length of the house. So we've already got the area of that rectangle. It's 15 units. So I've got 15 times square root 10. That's equal to 15 square root 10 units cubed. Okay, and we'll find the approximate volume here now. That is approximately equal to 15 times square root 10, 47.4. Okay, 47.4, 15 times square root 10. Approximately equal to 47.4 cubic units. And now we'll just add these together. So the volume total is just the volume of the roof plus the volume of the house. And that would be 7.9 plus 47.4. Again, this would be, I should say, approximately equal to, right? These are all approximations, right? And that would be approximately equal to 7.9 plus 47.4, 55.3. Cubic units. Could be anything, could be meters, feet, right? So this is the answer. And I'd be very eager to see if anybody got that on their own. The key, I think, that would be confusing would be to know to find the distance, all right? But that really does bring us all the way from the trivial to the truly interesting, the truly complex. For my advanced math students, I wanted to give you something to sink your teeth into, some problem that actually requires quite a bit of thinking, right? And the application of the distance formula. Yeah, I hesitated on solving it here on camera because I wanted to see if somebody would do it, but you know, I want you to be able to get the information you need. So we've done a whole lot today. We've covered an enormous amount of material. We've learned how to translate figures, rigid motion translations on coordinate planes. We've done segments, which is what we did here with no graph. Then we did a triangle, and then we did a quadrilateral. We took it to the next level by finding the volume of the shape that we formed in this homework problem. All right, neat. I found that last part to be the most interesting. And we started the day off on this fairly rigorous algebra review, right? Including the use of the conjugate, which is really cool. Lots of square root and square rules with radical signs. Some good stuff here. So I hope you learned a lot in this video. That's the purpose. Again, today was about learning how to translate figures using a vector, and I think we more than covered that. When we come back and rejoin, we're going to do transformations that involve multiple translations. So we'll move it. We only moved it once in this video. Next, we'll move the shape more than one time, twice, 3 times. And after that, we'll move on to different types of transformations. So this is a fairly simple translation. We're just moving something, right? Moving it around. Next, we'll learn how to rotate that thing. You can combine these moves together, so you can move something, then rotate it. And then we'll learn how to flip something, right? And finally, we will learn how to skew something, we'll also dilate something, we'll make it bigger, like a rubber band being pulled, getting bigger. But then we'll learn how to twist things and pull things. right? So it's going to become interesting, more and more interesting as we go along. Okay, well, thank you so much for watching. Please make sure to check the link in the description for a full set of these notes keys. Make sure to take a look at the chapter material, chapter 4 from Big Ideas Geometry. Leave a question in the comments section if you have one. If you have not already, please like the video, guys. It really does let me know that you're watching it. It lets me know that you appreciate what's been offered to you here. Like the video if it was useful to you, and if you have not already, make sure you subscribe to this channel and hit that notification bell so you're always alerted when I release new videos. Thank you.